down to funk in this bitch. My cat meowing in the background. Shout out to Meow. Down to Funk and Co's Ohio Grow Show number 7. Can you fucking believe it's number 7 already? We heard Meow, she can't believe it. You heard it firsthand right here. She said she cannot believe this shit. Here, let's get this. Let's get this up in here. Bam. How's everybody doing today on this beautiful Sunday? Everybody kicking it? Feeling good? Yes, sir. Yes, sir. What up, Coltagen? You smoking on anything? What we smoking on? What we smoking on? What's good, zombies? How's it going, brother? Appreciate you being here. Yeah, just chilling, having a good old time here. Getting stuff ready. 37th parallel, Moon Treaty, and Saurian runs. Oh yeah, that sounds amazing. Sounds super, super fire. Oh yeah. Everybody pack your bongs. Everybody do me a huge favor. Share this out. Let your brother know. Let your sister know. Let everybody know. It is that time of the week. It is that time. I am about to load up my dab rig here, and I got some basically just reclaim I've been smoking on. That shit gets me good. And I enjoy it. I enjoy it quite a bit. So that's what I'm about to pack up here. And that's what we're gonna do. And that's what we're gonna do. So we're gonna get this stuff started here. Takes a minute to load this thing up, get it turned on and all that bullshit. Enchanted Mikey, what's good, brother? What are you guys smoking on today? How is everybody doing? Welcome to the party. Not missing too much here. DtF and Co's Ohio Grow Show number 7. Today we will be talking about incomplete dominance, codominance, briefly reviewing the Hardy-Weinberg equilibrium, building from there, and then basically just keep on moving. We're getting to the meat and bones of everything, so we're gonna really start diving into some more complex concepts and more in-depth just plant knowledge and breaking stuff down more. So I'm excited. I hope you guys are excited. Mikey, your grow's looking amazing, brother. Enchanted, your grow's looking amazing, brother. Everyone that I consult with and we talk to and we go back and forth with, everybody's grows is looking amazing. Shout out to everybody that be rocking with us in the show and be rocking with each other here. For sure, for sure. You already know this is the time of the podcast where we just like to reconvene for the week, talk shit a little bit before we get started. And yeah, that's exactly what the hell we're going to do. Big chillin'. Definitely don't be afraid to follow each other, everybody. I'm going to make Enchanted a moderator. Yeah, make sure you sub up to everybody here in the chat. But yeah, so everybody, if you're ready, I'm about to cheers it up. If you guys are ready, let's get it started. Let's get it started. You already know I got my coffee too, of course. Oh yeah, we're on it. We're on it. Bam. Special thanks to Cultures Seed Co., Dab Marino, PNW Cultivar, and especially thank you to everybody out there watching right now. Mad love for you guys. I appreciate you. If I was just, if you guys weren't here, I'd just be talking to myself, and that's okay too. But it's a bit more entertaining and a bit more of a spectacle having people around. So appreciate you guys being here. Oh, you already know, Dab 30. I've given everybody plenty of time now. Get that shit loaded up. Get it loaded up and let's get popping. Because I am ready to start the show. Here we go. Got some new coffee today. It's fucking amazing. I really like it. You can hear that bitch crackling. Cheers, everybody. Once again, shout out to JoJo for all the awesome photos and artwork that he's done for me. All the special artwork that you see here on my page, on Insta, on anywhere. It's all artwork done by JoJo. So shout out to JoJo. He just got done working on one of the homie Jester's stuff too. So shout out to Jester as well. But yeah, man. Love involving everybody in the process, and love it when we can break bread together, you know what I mean? It's always best to include people. The more inclusive that we are, the more of a reach you have, and the more power you guys have together. You know, you build together, and you build stronger. So, and if you're all supporting one another and doing that type of stuff, then it just kind of uplifts one another. So, shout out to him. Okay, that was the Dabarooski. Let's get started. So, Review from last week's presentation, the Hardy-Weinberg equilibrium review. So what was this? So the Hardy-Weinberg equilibrium, or HWE for short, is essentially telling us, and it's saying that it's a constant population from generation to generation. So there's no significant changes and there's no outside interfering factors that make it deviate from HWE. Now, mostly, the Hardy-Weinberg equilibrium is an idealized state, and it's not really often met in reality, but they can use this as the control, essentially, to measure whether or not something's changing or evolving. So here's 5 different factors that are considered when you're looking to see if a population is in the Hardy-Weinberg equilibrium. So Hardy-Weinberg equilibrium is met when there's no mutations, there is random mating, there's no gene flow, there's an infinite population size, and there's no selection or selective breeding. An example of this would be Mendel's pea pod color for the frequency of the yellow dominant pods and the green recessive pea pods. And that's all we're going to talk about for that. Now let's get to the new material. Okay. Some new terminology. So we've talked about dominant and recessive before, but what happens when you have 2 dominant traits, but then they're both expressed? So there is no recessive because they're both being simultaneously expressed. Well, when this occurs, this is called codominance. And codominance occurs when you have a heterozygote that has the 2 alleles or trait of the gene that are both dominant. So instead of there being a muted recessive quality that the dominant allele is masking, there's 2 dominant alleles that are both being shown, and you can see them. So an example of this would be camellias. They can be both white and pink, and this is the example of codominance. Instead of one or the other being dominant or one being recessive and masked and carried on, they're both expressed and they're both dominant. Now we're going to come back to codominance, but another new term is incomplete dominance. Let's see what's popping in the chat. Oh shit, what's going on? What up, my Stamen? Emery, what's good? Bluesman, my brother, what's good? Lady in the Rain, big shout out to you, brother. Big shout out to Lady in the Rain. Oh yeah, trim gel, dude. Trim gel is the best. Which one you trimming up right now, Enchanted? Intense grape high chew smell from the 9-pound hammer. That sounds absolutely magnificent. That sounds great, Bluesman. Yeah, I just want to say hi real quick to everybody real fast. So incomplete dominance. Incomplete dominance here is when there's different phenotypes displayed, and because of this, there's an intermediate phenotype as well. So what happens here is that there's phenotypes of a heterozygote, phenotype of a homozygote, and then intermediate homozygote. So because of this, there is a really distinct phenotype that will be made. So like, for example, you can think of snapdragons. If you take a, oh yeah, here, let's review. Homozygous means two alleles of a gene that are the same. Heterozygous means two alleles of a gene that are different. So when you look at the homozygous white and the homozygous red snapdragon, it actually will make a pink flower instead of being red or white. Well, actually, there's red and white too. That's also ratios in the equation, but or in the punnet that come out of it. But there's just different. This is just to iterate that there's different instances for different plants and for different situations. Not everything's gonna be cut and dry, so just be aware of that. So like I said, we're going back to this now. So this right here is a picture of camellia flowers, and this is a good representation of incomplete dominance and codominance. So just take note of the one on the left being all pink, and then take note of the one on the right being pink and white. So which one, just based off what we talked about so far, and you know, nobody's gonna get in trouble or nothing, or you know, get a bad grade, but just in your head or in the comments, just tell me which one do you think. Well, actually, you probably can see the presentation. Don't read the words under there. Don't read those words. But which one do you think, based off what we just discussed, is displaying incomplete dominance, and which one's displaying codominance? Just put left or right in the chat here. Let's see what we get. I would love to smoke some 9-pound hammer, dude. That sounds so fucking fire. 9-pound hammer makes me think of a song by Bob Marley called Hammer. Really good song. Or you guys take a minute to decide which one is incomplete or codominant. Just put left equals this, right equals this. While you're doing that, I'm going to prepare this dab for later here. I'm not going to hit it again, but just get it ready so I don't have to get it ready later. If you already read the answer, then congratulations. But if you didn't, just do your best guess. Oh, everybody say what's up to Coltrogen too. He's in the chat chilling. He's 734 SMG. Say what up, Coltrogen. So, if you said that the flower on the right is displaying incomplete dominance, you would be correct. If you said that the flower on the right is displaying codominance, you are correct. Give yourself a round of applause. Clap, 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 clap. Just imagine that was a clap soundboard. So, let's just read this down here. So, 2 camellia flowers show the difference between incomplete dominance and codominance. The heterozygote shows an intermediate phenotype if the trait displays incomplete dominance, which we can see on the left. If the trait displays codominance, then both phenotypes are simultaneously expressed in the heterozygote, which is pictured in the right. So because both alleles are dominant, they are equally expressed in codominance. In incomplete dominance, there's a variation of a mixture. So, next thing we're going to talk about is bottlenecking and bottleneck. So what is that? What does that have to do with genetics, and what does that have to do with plant breeding? Well, by definition, bottleneck is a reduction in the population size which leads to a loss of genetic diversity. And this can be caused by a multitude of things such as environmental factors, human interference, and etc., etc. Human interference and environmental factors is a pretty broad, too broad statement, so it can be so many other things that cause this, but it's a reduction of the population size, and it's reducing the amount of genetic diversity available. So I think we could sit here and contemplate and figure out why this is not good if you are trying to breed plants. So before we even talk about it, just based off what this is, let's apply it to some cannabis real quick. So that is something that Cultigen has talked to me about, bottlenecking, and it's something he is concerned with, and it's something that he said that it's pretty easy to do, for one, and it's easy to do and it's hard to backtrack from. So one of his suggestions for me in regards to the Beginners Breeders Project is to make sure that whatever I'm doing, I'm taking clones of everything. So what's the pros and cons of taking clones? Well, let's just start with the cons. Obviously, the cons is going to be that now I got to I got to keep these fucking clones alive. I got to get these clones to root. I got to not only get them to root and stay alive, but I got to make sure that that one's alive and then the one that I took the clone of is alive, because the goal is that the other cons of that is that you have space and time constraints, because now you got these clones. So space is always the number one factor for the majority of people, I'd say, so myself included. So if you can run out of space pretty quick doing some breeding projects and taking clones of, let's just say your plant max is 12, taking 12 cuts of clones off of every batch of stuff that you do, that's going to take up a lot of space over a long period of time of you having to do that. Because if you go and you take clones from the parents, and then you go and take clones from the first generation, then you go and take clones from the second generation, and so on and so forth, well, I mean, depending on how many clones and how many beans you had popped, I mean, that's going to add up really fast. So that's the number one con is the space constraint. Along with that, the reason to clone and the reason that you want to clone is because of this bottlenecking term. So since bottlenecking is the reduction in the population size and it leads to a loss of genetic diversity, taking clones of all of your cultivars is going to help. It's the exact opposite of what the reducing the population size. Instead of going and taking one from seed to veg to flower and then harvest and never see it again, you now have clones of all of these. So you are actually keeping the genetic diversity in the gene pool diverse and alive by taking these clones off. And that's essentially what Cultigen was telling me. He was saying that, well, you don't know if you go and, let's just say I have a skunk, let's say skunk number 3 is really, 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 really drought resistant, But then as it got closer to flower or this, that, the third, it became really finicky, and now I don't like it, or whatever it may be. He was just saying that it's very important to take these clones to have as many different options, or for example, to have as much genetic diversity as you possibly can. So another thing, we were just talking about this the other day. We were speaking on, because I was trying to work out in my head what's the best way to move forward with the original skunk project, because the main goal right now for the skunk project is to take them and to get more seeds out of them, because I only have 10 seeds, so I'd like to have more seeds to then go through and hunt through those. So then I was asking him, well, should I save clones from each of these original 10 seeds? And he was saying, well, yeah, I would, because then if you go through and start finding keepers from the next first generation of offspring or the second generation of offspring, if you wanted to take one of those from the second generation and cross it and double back and cross it to one of the original parents from the first generation, you can, because you still have that. And now you didn't bottleneck anything, because you still have access to all of that gene pool. If you were, and that's theoretically if you keep all the clones and all the cuts and they all survive. Now if you just go through and you did like I did for the apes in space here on my last harvest here, I took the apes in space to complete seed, veg, flower, harvest, dry and cure, and I didn't take a clone of it, so now it's gone. So if I don't have any more seeds of it, I'm hit. Unless I go and buy more seeds, I don't have any more of those seeds. So I've bottlenecked myself. And not only that, if I even do get more seeds, there's no guarantee I will get an exact representation of what I seen when I was growing it the first time. So that's kind of my side tangent about bottlenecking and how I'm applying it to Beginners Breeders Project and recent conversations I was having with Coltigen. It's important to not bottleneck, because it reduces the population size, and then that leads to less genetic diversity, which is always bad. You always want more genetic diversity, because then that means more possibilities and more more possibilities. Essentially, that means more options to search through. So the less you have access to, let's say, Acapulco gold, because that's an old school one that a lot of people have trouble finding, or if you do find it, you have to be weary of who you get it from, and you have to have that second thought in your head, oh, is it really that? So and that's because of bottlenecking and of people not taking proper precaution to make sure there was not a reduction in the population size. So bottlenecking, reduction in the population size, leads to a loss of genetic diversity caused by environmental factors, human interference, a multitude of things. What are the implications for this? So obviously, like we talked about and have reiterated, loss of genetic diversity. So this is bad because let's tie it back to cannabis. This is bad because if you have plants and you're in an area where, let's just say you live in Arizona or you live out west and you live somewhere where it's really super humid or whatever, it's not going to be beneficial for you or easy to find something that you would want to use if you have like, let's just say, for example, you have a cultivar you've been working with for years and you're like, damn, I really like this, and you have it and you're trying to work with it with something else, and then next thing you know, something happens when you were crossing it, and the next offspring of it is actually weaker or less than what you expected or anticipated. Well, this is going to end up potentially being detrimental to your grow, because as you continually move further down a genetic line, if you're not doing your proper selections, and if you're not doing the proper care or caution to not bottleneck, you could eventually get to the point where you accidentally bred something that's really susceptible to diseases and pests, or just a really finicky or herms, like, and you could have done it on like complete whim or accident. You didn't mean to, and this is a result of not having unique alleles. So one thing they talk about, like between LED lights and HPS and all that stuff, is that there's certain cultivars from back in the day where they were specifically only grown under HPS or metal halide, and for them to go and be switched over to LED, the theory is that it may be a little bit difficult for them to adapt or to adjust to that because of its already predisposed genetics to one particular environment. If it was grown for 30, let's just say 30 years, let's just say from 70 to 2000, let's just say there was one cultivar, they grew it with HPS lights from then to then, and then LEDs came out, and then they tried to do it with LEDs, like, man, this shit sucks. Like, it could be because stuff was bottlenecked, and they only selected the ones that grew the best with the conditions that they had, which was metal halide or HPS or this, that, the third. So then when you do go to try to implement something new, it doesn't work the way that you remembered, because now you don't have the same variables anymore. You've changed something. So that's something to consider too about bottlenecking. That's and that has nothing to even do with I mean, it's nothing that's bad per se. It's just something that was human interference. So once again, tying back to a cause of bottlenecking is human interference. So we have to think about these things. And I'm a bit younger, and I'll be honest with you, I've never used the old school techniques of lighting and stuff. So I can't even say firsthand experience about any of that, but I think it's important to note, so that's why we're talking about it. So another implication of bottlenecking is genetic drift is more likely to occur. So this is actually caused by chance fluctuations inside of the allele frequencies, and essentially it just means that the genes are being expressed, the traits of the genes are being expressed a little bit differently, and it's being caused by genetic drift, and some of those traits that might be being expressed are not ideal for the environment they're in. As well as another implication of bottlenecking is overall reduced adaptability. So you'll just have plants that are not very good at surviving or evolving, and those are the type of plants that would not make it outside. So if you have plants that are growing inside, I mean, and it's kind of hard to put in this frame of mind, but if you have some plants growing inside, I guess you could, my way of looking at it is, if I could take those plants and grow them outside and they're completely okay, there's nothing hindering them, then that's some pretty good fucking genetics right there. But if I take it and I went from indoor to outdoor, and obviously you gotta acclimate it too, but if you take it from indoor to outdoor and it just fucking straight up dies and shit, then I would probably say that's probably not something you want to work with. And that's something Cultigen was talking to me about too, just going through the motions of testing all this shit. So light stress, drought stress, high stress training, low stress training. Like, there's so many different stress factors that you have to test. And we were also talking about it's impossible to test all of them because of all the different environments that people are growing in. It's impossible. You'd have to have so much space and so much controlled, sealed environment. So it's just take in mind and take heed of this, and that bottlenecking is pretty easy to do, but it's hard to reverse. It's the same concept as once something's gone, it's gone. So you got to think about it like that. Think about it as the strain of the think about it as the cultivar that you wish you never missed out on, you kept. There's always that one that got away. Think about it like that. It's kind of like that. You don't want to have the one that got away. So that's what you're trying to avoid with bottlenecking. You don't want to do that. So next. So along with bottlenecking, once a population is bottlenecked, there's this thing that can occur when there's a new group or colony from the original population that's formed. So once a population is bottlenecked, you can have a founder's effect occur because there's only a few representations of the original population size, and because of the bottlenecking of this, that means that there's less genes or less genetic diversity to be, basically combined and to be passed on. So then that leads to a reduced variation, in the population, and it leads to, or it could lead to, an untrue representation of the original population because of there being so few original examples of it. So that's another thing to take into account too. Founder's effect. So next thing we're going to talk about is a gamete. We just talked about bottlenecking for a minute there. I'm going to take a sip of this coffee. Okay, so what is a gamete? Let's see if we got any questions here on the live. Edibles and beer, hell yeah. Yes, sir, Coltogen, you're out here killing it, son. Killing it. Out here spreading the knowledge. I told you, Coltogen, he got the knowledge. You ask him, he'll tell you. If he has knowledge about it, he's gonna tell you. And that's what I like about him. He's not afraid. He's not afraid to tell you what he's thinking, and you know what? I like hearing what he has to say. So make sure you shout out to Coltogen. Yeah, dude. So we're gonna keep on going here. I'm almost out of coffee. I'm a little bit sad about that. But I am thinking just a little bit here. It's about time for Dab fucking 30. So everybody load your shit up. We're gonna hit one here. And while we load one up and we're gonna hit it. So today's original game plan for this was to, at the end, start talking about mutations, mitosis, and meiosis. But then as I was doing this, and as I was going through and breaking stuff down a little bit more, I was like, you know what? There's plenty of stuff to break down leading up to talking about mitosis and meiosis. So those two subjects are two subjects that I damn near could do a week on each one. So I could do a podcast next week and then the next Sunday on each one of those subjects. And I'm not sure if that's what I'm going to do yet, but I just thought it'd be too much information and just too much overall just to shove into one podcast for this week. So we're going to be not going as far as I necessarily wanted to, but it actually worked out better that way because I feel like it's really moving in the direction that I want it to with building up and, just taking logical steps forward. So I feel like I'm moving at a decent speed, not too fast, not too slow, and I feel like I'm building on concepts. Please leave me comments and feedback on the video, and if you got my Instagram, hit me up on there. Like I 100% want to hear back from you guys, good, bad, the ugly. Like I want to hear everything. So feedback is appreciated, and I appreciate you guys. So let's hit this shit and keep going here. But yeah, that's just to give you a little update because I think I put in the YouTube bio that we were going to be talking about mitosis and meiosis, and we're going to briefly mention it, but then that's going to be subjects that are spoken about in the next week, on next week's podcast and the week after that. So yeah, we're building up to that stuff, but we're getting there. So and really the reason we're talking about all this is because this is like the intricate details of the plant breeding stuff. So not necessarily you're going to be using this every time you go to cross a plant or breed a plant, but it's important to, like a mechanic knows why everything in a car works, and if something out here is not working, it may be because of X, Y, Z. So we're trying to be like mechanics for this motherfucking plant breeding, son. We're trying to formulate all that type of information and have all the knowledge and then utilize it in our day-to-day lives. And that's what we're gonna do. That's what the fuck we're gonna do. I'm feeling good, feeling great. How the fuck are you? Smack this dab, we'll keep fucking going. Honestly, been a pretty decent week. You know how it goes, man. Motherfucking work. This, that, the third. Oh, shit. We turned it off. Ate some fire chicken today. I was hyped up about that. Went and ate some breakfast, too. That was super good. Super good. Alright, cheers, y'all. This motherfucker's about to go off here. Excuse me. That was a burp. What's a gamete? I'm gonna tell you here in a second, mate. Ha ha ha. Hilarious. It's always nice taking a fat rip. Woohoo, damn. So you may be asking, DtF, what the fuck, man? I don't care about none of this shit. I don't care about none of this. I don't want to know none of this. Well, hold on a second. Hold on a minute. Let me tell you what it is first. Let me tell you. What's a gamete? So in plant biology and plant genetics, a gamete is a haploid reproductive cell. So what's haploid mean? Well, I think we mentioned that maybe towards the beginning podcast, like maybe 3 or 4. But haploid means one set of chromosomes. So, for example, haploid would be the male pollen, that's haploid, and the female ovules, that's haploid too. So, a gamete carries the half the number of the chromosomes. So if there's 2 gametes, that means it's a half and half, and when they come together, that's 1. So that's 1 chromosome. So half from the mom, half from the dad equals, so half chromosome plus half chromosome equals 1 chromosome. So when the 2 gametes fuse, this process is called fertilization. And then it forms something called a zygote, which we'll talk about here in a second. So, what is a male gamete? The male gamete is exactly what you think it would be. Think about cannabis plants. It's the male flowering pollen. That's what it is. So, male gametes are found within the pollen grains of the flowering plants, which are made inside the anthers of the flowers. And this is stuff we can pull up more diagrams and we can talk about more. In the next one, maybe that's what I'll do when we do the review of it. I'll pull up like pictures of it with the definition by it and stuff. So female gametes are the inside ovules located inside the ovary of the flower. So these are the 2 things that fuse together, the 2 gametes, and the process called fertilization. And then once they do, they form a zygote. So once this zygote is formed through fertilization through the 2 haploid gametes fusing together, one from the mom, one from the dad. The zygote is big chillin'. So let's talk about fertilization. Fertilization, though, is when the pollen lands on the stigma of the flower, and then the pollen tube grows down towards the ovule, and then the male and the female gates, they do their thing, and they got the zygote. So basically this is like when you have a male cannabis plant with its pollen sacs, the pollen disperses. That pollen is gonna hit the white pistils, the white stigmas on the flowering cannabis, female cannabis plant, and then once it hits that, that's when fertilization is happening, and when this pollen tube will then start to form towards the ovule, and then the zygote is formed. So with plants, they do this double fertilization. So what happens in flowering plants is that there is one male gamete that's gonna fuse to a female gamete, and this is gonna make the embryo of the plant. And then there's another male gamete that fuses to the central cell, and this makes endosperm. So once again, DtF, why is this? This don't have nothing to do with plant. Yes, it does. So endosperm is actually, like how people have said to me, I heard this when I was researching and starting to first grow and all that stuff. Once you plant a seed, you have about 30 days encoded in that seed's genetics. It has about 30 days of nutrients to feed itself. The cotyledons, and that it's providing food to the seed to feed itself. So you have about 30 days from when that little seed will pop its little head out and stuff to have to then give it more nutrients. So this endosperm, once the male gamete forms to the central cell, the endosperm that's formed is actually what is giving the food to the seed, to the developing seed to grow. So that's pretty fucking cool. I thought, I was like, damn, that's dope. Moving forward, gametogenesis. We've talked about this before as well. And now we're gonna finally go into it a little bit more here. And this is the stuff leading up to meiosis and mitosis, or mitosis. And once again, I apologize for reiterations, but it's important to keep certain subject matters prevalent, just because of the nature of what we're talking about. Everything's building off of each other, so it's just good to have refreshers sometimes. So yeah, gametogenesis. Let me finish this coffee quick. I'll tell you what, real quick. I'll let you in on a little secret. Coltogen, he's working on that shit, man. He's working. He's working nonstop, son. Nonstop. So don't think he hasn't heard all you guys. He knows he's on it. He's been on it. Just be patient. Be patient. As soon as I know, everybody here will know. Because you already know I'm going to be promoting it like a motherfucker. So be patient. Alright, so gametogenesis. So, this is haploid gametes or sex cells that are produced from haploid or diploid precursor cells through mitosis or meiosis, depending on the plant's life cycle, with the haploid gametophyte generation producing the gametes. So, what in the fuck does all of that mean? Well, let's break it down. Like we already said, haploid means one set of chromosomes. So then diploid, we should logically assume di means two. Diploid means two sets of chromosomes. So essentially you can have haploid or diploid precursor cells through mitosis or meiosis, which is stuff we're going to talk about in the next presentation, depending on what the plant's life cycle is. So obviously for cannabis is going to be different than a pine tree. A pine tree is going to be different than a tomato plant. Like, so it's just, that's what it means by a plant's life cycle. All of it's going to be a little bit different. So let's talk about this. Haploid gametophyte generation producing the gametes. So in gametogenesis, there's an alteration of generations, and it will alternate between haploid gametophyte and diploid sporophyte. Gametophyte development is haploid. Sorry for the misspell right there. I just saw that. And gametophyte development is just talking about the the sperm and egg gametes. So it's just talking about the male and female development of gametes. Sporophyte development is just talking about, remember diploid means 2 sets of chromosome. Diploid means or diploid sporophyte makes haploid spores through meiosis, and this will make more sense once we talk about meiosis and whatnot. But yeah, so gametophyte is just male and female gamete productions or development, and that's haploid with 1 set of chromosomes. And then yeah, dude, that's not, I mean, there's really, oh shit, my bad. And then really that leads into this. So if we have gametogenesis, mega gametogenesis, like we said, or gametophyte development is sperm and egg gametes. So if that means male and female, well, mega gametogenesis is the female gametophyte develops into an embryo sac which contains an egg cell. Microgametogenesis is the male gametophyte develops into pollen grains which contain 2 sperm cells. So it's just talking about male and female developments. So we have mega and micro sporangia. Mega sporangia. Damn, I spelled something else wrong. My bad, dude. Fuck. 0 for 2. So this is the female gametophyte develops within the megasporangia in the ovules. Microsporangia is the male gametophyte develops within the microsporangia in the anthers. And like I said, I'll have diagrams on the next presentation of some of this stuff so we can get some visual representations, and I'll make sure that it's cannabis plants. But that's that there. And you guys, that's about the end there. Like I said, we're gonna kick it till 8:30. We'll make it an hour here. We'll kick it till 8:30. So I'll head up to the chat right here. I'll see what everybody's up to. We'll just kick it in chat for a second. Oh, dude, homemade pizza sounds fucking fire, son. What up, Adirondack? What's good, brother? But yeah, so we're gonna sit here and talk for a second until about 8:30, and then I'm gonna hop off here, guys. So yeah, that's what this is. If I started talking about the mitosis and meiosis stuff, that would take us a little bit longer than I'd like to go, I think. So we'll run that into next week and maybe even the week after that. I'm trying to decide, and I'll probably make up my mind either tonight or tomorrow about whether or not I'm gonna make it 2 separate weeks or just 1 week. So we'll get it figured out, and I'll let you guys know when I figure it out. But yeah, go to my Instagram after this here. I will have a update on my current veg room. Currently have 2 clusterfuls by Exotic Genetics, 2 more Apes in Space by Exotic Genetics, a Platinum Bingus, 2 P&W cultivars, Fruit Pump, Pink Glizzies. I have an Offensive Selections Angel's Rest, which was a freebie I got from getting some P&W stuff from Dark Coast. And then I also have a Kugati by Native Sun Genetics that I'm really excited about. And I've planted extra just in case I have males. I don't want no males or nothing like that. So, yeah, they're all looking pretty good. Real green. There's a couple of them Oh, and I got some Chill Mints OG going to my own cross that I made with the Chill Out OG F3s by Mr. Grow It. Cross to my own Runt Mints. And Runt Mints is a male CRV Mints cross to a white Runts. And Runt Mints was an open pollination accident, and that's what began the journey of the Beginners Breeders Project. And then from there, I grew the Runt Mints with the Chill Out OG F3s, like I said, and they were regulars. I had 2 Chill Out OG males. Killed the lesser than of the 2, and then kept some pollen and pollinated the Runt Mints, and then made these Chill Mints OG seeds, and just decided to just now start growing some of them. So yeah, here we are, and I'm growing some out now. Not doing anything to them. I've done very minimal anything. Most I've done is just rip off some leaves of them. Haven't topped them. Not training them. And this was a suggestion by Cultigen as well too. Just trying to look to see the natural morphology of the plant. It's going to be kind of hard to see what the plant can do and what it wants to do if I'm over here topping it 20 times and fucking bending it sideways like a fucking contortionist and shit. So just got some of those just going. Just want to see what they get into. Got to be careful when I go eventually to flower, because like I said, I got to watch out to make sure none of these are male, because this is the area that I don't want pollen in. So that would be bad, of course. So yeah, I'm really excited about it. I mean, like I said, I'm gonna get off of here when I do, and I'll take a little video real quick and post that on Instagram. We got 3 more minutes here, so I'm gonna keep talking and chilling and shit. Everybody load one up if you got one. Spark one more here. We got 3 minutes. That's enough time to chill. Shit. Dude, that sounds fucking fire, son. Some dino nuggets and some soup, son. Hey, I appreciate you, Bluesman. I appreciate you. I look forward to Sundays too, you guys. So appreciate you guys all being here. Let's hit this dab and send you guys on your way, because I'm about to go eat too. I'm about to go eat myself. So yeah, we'll get this picture up of this. I don't know about my re-veg project. One of them's looking okay. The Georgia Pie's looking alright, but the Milktopia I'm trying to re-veg she's looking a little rough. So I'll show you guys that one too whenever I go in here. But yeah, I'm not sure how much bigger I'm gonna let these grow lengthwise here. I'm gonna measure it real quick, and I'll tell you how high up they are, how tall the average plant is here. I have to be careful of my height. I am growing in an open room, but height is still a constraint for me. I got about maybe 6 foot, up to 6 foot. The lights hang off the ceiling probably about 6 to 12 inches or whatever. So really I only have about 4.5, 5 foot of vertical height to go. So I gotta measure these real quick, and I'll let you know how tall they are, and I gotta eventually decide how when to raise these lights again, and how much more I'm gonna let them grow up vertically. I have one trellis net that I never took off and one that I did take off. Still debating when to put the other one back on. I'm thinking I'm gonna wait a little bit longer here. But yeah, let me measure these real quick. Then I'm gonna hit this dab and we can skedaddle. Yeah, I'd say they're all, the average height is about 24 inches or 2 foot for per plant right now. So I can go. I gotta be careful. Probably can't go much more than a foot more growth vertically. If I go much more than that, I'm gonna be pushing it when I switch to flower, with them doubling in size potentially. So yeah, that's what we got going on here. Gonna smack this dab. I'm gonna take this video for y'all, post up on Instagram. I might post it on YouTube too as a short or a video real quick. I'm not sure yet. If it is, I'll post about it and put it up on there for you guys. But yeah, let's do it, man. Everybody load one up. I'll put your dino nugs down real quick. Adirondack. We're gonna smack this fucking dab. We're gonna smoke this weed real quick. I mean tree, whatever. You don't ban me, YouTube. Don't ban me. Support everybody. Support one another. Support local. Support yourself, man. If you ain't gonna support yourself, who's gonna support you? You know. So yeah, let's smack this dab and go on in peace. Start this week off good. Start Monday off good. I wish everybody a amazing work week. I wish everybody an amazing rest of their evening. I wish everybody many blessings. As we go into this new week, I'm fucking blown away that it's already March 16th. It's about to be fucking March 17th tomorrow. It's pretty crazy. Time flies when you're having fun, huh? Shit. Alright, let's smack this shit. I know I said it like 12 times now. We're already at 8:31. Do. Oh yeah. Fat dabs in America. Yeah. Cheers, everybody. Ooh, shit. This thing's hitting today. Damn. I love it when you get those hits that take your breath away a little bit. Oh shit. Woo. Well, I think that is a wrap, everybody. We're gonna call it a night. Thank you for tuning in. Thank you for being here. Down to Funk, DTF and Co's Ohio Grow Show number 7. That's a wrap. Conclusion. Thank you for riding with me. Thank you for being here. Like I said, go check out the Instagram after this. Gonna have a little something up of the current veg room. Go support everybody that's in the bio. Follow them up. Everybody that got the blue moderator, follow each other. Shout out to Cultigen. Shout out to P&W Cultivar. Shout out to Dad Marino. Shout out to everybody here in the chat. Shout out to everybody watching. And shout out to everybody that may potentially watch this in the future. Like I said, please leave a comment about anything I can improve on. Anything that you liked or you learned, or just something that you want to say. Leave it down in the comments. You already know what time it is. Make sure you're smoking fat ones all week for me. Make sure you're taking care of yourself. Peace and one love. Oh shit, it's Detroit. What's good, Detroit? How's it going, brother? Hey, thank you. I appreciate all the love, everybody, for real. Thank you. Yeah, I really appreciate it. What up, Detroit? I appreciate you stopping by, brother. I was just about to end the broadcast, but I saw you was here, so I was like, yeah, buddy, I'm gonna say what up. Just smacked a fat dab, dude. If you're live later, I'll slide by, bro. I'll say what's up, smoke some dabs with you and shit, man. Everybody, make sure you follow Detroit Dabs, man. He's a good dude. He's always just spreading good vibes, just chilling. I like him a lot, man. I support him for sure. Alright, one love, everybody. Peace.